So today we are going to discuss about the curve fitting. Right. First thing, what is the meaning of curve fitting? Before discussing about the curve fitting, let us just think about the three things. The first one is the curve plotting. Curve plotting. Second one is the curve tracing. And the third one is the curve fitting. So what is the difference between all these three terminology? So curve plotting means, let me take one example. If we have x plus y equal to 3, this is the equation of a straight line. So if you want to plot this straight line, we have to make a table in which for different values of x, we obtain the different values of y. For example, suppose if you put x equal to 0, the value of y is 3. If you put x equal to 3, the value of y is again 0. So if you want to trace this point on the x-axis and y-axis, this point 0, 3, 0, 3 is this point, is 0, 3, and this point is the 3, 0. And if we join these 2 points, we are able to get the equation of our geometrical representation of a straight line x plus y. So this is called plotting of curve. Plotting of curve means we have to take the different values of the x and y and we have to plot on the graph paper. So it may be, this is a straight line, it may be another system of equations or 2 variable, 3 variable, whatever it depends upon the how many variables or which type of equation given to us. Now the another thing is tracing of curve. Tracing of curve or curve tracing. Tracing of curve. So what is this? Suppose we have given a parabola y square equal to 4x. So the one method is what? We will put the different values of x. Correspondingly, we will get the different values of y. So now if we have the set of different points of x and set of different points of corresponding value of y, then we are able to plot that graph and we are able to get this parabola. Sometime we can also write or draw such type of curve by using some definite properties. Like that, suppose this is what, since x and y are present, if you put x equal to 0, y equal to 0. So this curve satisfy the equation of origin, means it includes the equation of origin. It includes the origin. And also since the power of y is even, so it is symmetric about x-axis like that. So we can also trace like this. Now, if this is what, it is a parabola y square equal to 4x. But we are not able to say that it is the exact parabola. It may be the different parabola, it may be like that, it may be in this manner, or it may be like this. But the approximate shape, finding the approximate shape of the given curve is called tracing of curve. So this is the another second point, which explain the curve tracing. The third one is the curve fitting. What is the meaning of curve fitting? Let me just take some values of x and y. Suppose it is 1, 2, 3, 4, 5. Suppose the value of y is 5, 10, 15, 10, 20. So we have given the different values of x and corresponding value of y. Here we cannot say that x and y are independent. Here x and y are dependent. Let me just take one example. Suppose we want to take the rainfall in the month of June in June 2023. June 2023. What was the rainfall in each and every day? So suppose in the first day there is 1 centimeter or 1 millimeter. In the 2nd June, another 5 milliliter. So now in this manner, this is what it is X and this is Y. So based on this data, suppose one day, 5th day, suppose today is for example, today is the 4th June. And now based on this 5 data, up to 5 data, we want to say that what will be the rainfall on 25th of June. Okay, so now this is not possible because we have the different data. Sometime it is 1, sometime it is 5, sometime it is 4, sometime it may be 0. So based on this data, how we are able to say that the what will be the rainfall on 25th of June. So the curve fitting is the best tool or best technique, or this technique is also using right now in the machine learning. Means what we can do based on this data, we are able to define function between a relation between X and Y. So that is called curve fitting. Okay, so let us start. What is the meaning of curve fitting? Curve fitting means finding a functional relationship between the two variables X and Y in the form Y is equal to f of X, where X is independent variable and Y is dependent variable, using a given set of endpoints x1, y1, x2, y2, x3, y3, and up to xn, yn. So this what curve fitting is what? Curve fitting is nothing but a functional relationship between two variable, where in which the different points are different points of X and their corresponding value of Y will be given. Means the values of ordered pair of two values x1, y1, x2, y2, x3, y3, and so on are given in terms of points. The functional form is to be fitted at best level using a principle, which is called principle of least square method. So now today we discuss about the one principle or one method, which is which is very much useful to find out the curve fitting. Principle of least square method is developed by Carl Friedrich Gauss in the 18th century and further refined by Andrew Mary Legendre. So what is the method of least square method? So it states that the sum of squares of deviations between actual values and estimated values by the curve is to be minimum. Right? So for example, y is the exact value and f of xi is the estimated value. So this y minus y f of xi, this distance should be minimum. So this is called method of least square method. So what is the principle of least square method? It is a statistical method to estimate parameters in a mathematical model by minimizing the sum of the squared differences between observed and predicted value. So what are the observed value and what are the predicted value? So we have to take the difference and taking their square, and it should be minimum. The principle of least square is foundational concept in the field of statistics, and its application is crucial for determining the parameters of a mathematical model during the process of curve fitting. It provides a systematic and mathematical approach to find the least best fitting curve that describes the observed data. So with the help of that observed data, we are able to find out the relation between the dependent variable y and independent variable x. The term yi minus fxi, which is equal to epsilon, is called error or residue of ith ordinate. Means this value yi minus f of xi means y1 minus f of x1, y2 minus f of x2, y3 minus f of x3. This is very small. It should be actually what we want to do. we want to find that this two value will be minimum. If it is minimum or if it is going to zero, then we are getting the best fitted equation of the curve. Now the objective of the curve fitting is to estimate the parameters in the functional relations that chosen by minimizing the total error. So what is our aim? Our aim is to minimize the total error, which is yi minus f of xi. So now let us take some important curves. What are the important curves which can be best fitted using the least square method? So some important curves applied in practical lives are, there are some important curves. The first curve is the straight line, y is equal to a plus bx, which is the first degree polynomial. Second, parabola, y equal to a plus bx plus cx square, second degree polynomial. Third, exponential curve, y is equal to a e to the power bx or y a e b to the power x. And power curve y equal to a x to the power b. So there are four type of curves. So all four type of curve we are able to get the base fitted for using the least square method. So let us fit these curves for a given data set using the principle of least squares. So let us try to do the fitting of curve of the principle of least square method. This means to find the best estimates for the parameters a, b, etc. by applying the principle. So first, let us try to we fit the straight line. So what is the equation of a straight line? Suppose the straight line to be fitted for a given data of n points x1, y1, x2, y2, x3, y3 up to xn, yn using the principle of least square is given by y is equal to a plus bx. So we have given a equation of a straight line y is equal to a plus bx. We want to find out its curve fitting. According to the principle, E is equal to sum of yi minus f of xi whole square is to be minimum. What is our aim? Our aim is to do that this E should be minimum. Right? So how we are able to get the minima or maxima? So I think everybody knows about that. If we have a given a function x is f of x is x square plus 2x plus 1, for example, then how to find its minima or maxima? For minima or maxima, we have to find out their derivative, f dash of x, which is equal to 2x plus 2. And in case of maxima or minima, we have to put this is equal to 0. So if you put this equal to 0, what we are getting? The value of x is equal to minus 1. So, and after that, we have to find the double derivative, f double dash of x. What is f double dash of x? It is 2. So since it is positive, so the function f of x, which is x square plus 2x plus 1, at x equal to minus 1 has the minimum value. Suppose if it is negative, f double dash is negative, so we get the maximum value at x equal to minus 1. So this is the method to find out the minima or maxima of any given curve. So similarly, we have to find out the minimum value of this sum of yi minus f of xi whole square. So for maxima and minima, we have to follow this procedure. So let me take it. That is, E is equal to sum of yi. What is the f of xi? We consider that f of xi is what? It is a plus bx. And now we are considering the data sets. Now we have not only one value of x or y. We have the multiple values of x and corresponding multiple values of y. So we are putting y should be written as yi and x should be written as xi. Now to minimize E, we have to solve DEDA. Del E, partial derivative of V, partial derivative of E with respect to A, and partial derivative of E with respect to B. and we equate both, then we are able to get what is the value of, what are the values of a and b. And then we have to prove again that the second derivative should be always greater than 0 if we want to find out the minima. If you want to find out the maxima, it should be always greater than 0. So here, since we want to minimize it, so this 2 value will be always positive. So now what is our aim? Our aim is to solve these two equations. We have to differentiate this partially with respect to A and with respect to B, and then we have to find out the values of A and B. So let us consider del E, means we have to differentiate partially E with respect to A. So what is the value of E? E is equal to sum of yi minus a plus bi whole square. So if we differentiate partially, let me just write down. Let us consider this total term is the x. So what is the derivative of x? Derivative of x square is 2x. Derivative of x square is 2x. So can I write like this? Just look here. 2 times of, this is what? This whole square. So we are considering this is x. So x square, what is the derivative of x square is 2 times of x. And again, if we apply the chain rule, what we can do? Again, derivative of yi with respect to a, since it is partial derivative. So if we are using the partial derivative of yi with respect to a, it should be constant. And this should be also constant. So only what is the derivative of a? So the first thing is what? This is the 2 times of x. Then derivative of yi is 0 minus derivative of a is equal to 1 with respect to a plus 0. So what we are getting? We are getting minus 1. I think this term is clear to all of you.
Yes, sir.
Yeah. Okay. Very nice. So now this 2 and minus 1. This is minus 2. So since the multiple of this two thing minus 2 of this is equal to 0, so the minus 2 will not be equal to 0. So that this term will become 0 because minus 2 is constant. So constant never will 0. So yi sum of yi minus a plus bxi will be equal to 0. Now let us open the bracket. So sum of yi minus a is constant, sum of 1, and plus b is also constant, sum of xi. So now sum, we are using sum over here. It is from n equal to or I equal to, this summation is from I equal to 1 to n. We are adding n terms. So now if we add n, 1, add 1 to how many times? 1 times. 1 plus 1 plus 1 plus plus plus. How many times? N times. So what is the answer? It is nothing but n. And if we add 1 n times, so what is the answer? It is n and a, b, sum of xi. So this is what we got one equation. Sum of yi is equal to na plus b sum of xi. So this is what? This is the one equation on a and b when we solve partial derivative of e with respect to a equal to 0. Similarly, we can also solve this for b. So partial derivative of e with respect to b. So same process we apply over here, but now here the variable is b, not a. So again, what is the derivative of x square? Again, derivative of x square is 2 times of x square, 2 times of x. And then again, derivative of yi, derivative of yi with respect to b is 0. Derivative of a with respect to b is 0. And derivative of partial derivative of bxi with respect to b, it should be xi. It should be xi. So here Since there is a minus sign, so we used over here minus xi. Again, now we have to multiply this xi minus xi. Again, just look here. The very important point over here is this is minus 1 and 2. This is constant. So it could not be 0. So we have to take an outside. So which term will be 0? Sum of yi into xi, then a xi plus b xi whole square. And now if we simplify this bracket, again we have sum of xi yi minus a sum of xi minus b sum of xi whole square. And if we transpose these two terms in the right hand side, we are getting sum of xi by I is equal to a times of sum of xi plus b times of xi whole square. So this is the another equation which we have obtained by using this equation, partial derivative of e with respect to b equal to 0. So now these two equations, the equation sum of yi is equal to na plus bxi and sum of xi yi is equal to a sum of xi plus b sum of xi whole square. This we obtain this by solving del e del a equal to 0, and this is obtained by solving this equation del b equal to 0. So these two equations are called normal form of the given equations. Solving these equations, because what we have given the values of different values of y, different values of x. So we can also multiply xi, yi. We can also find out xi whole square. And then if we put all the values, we get two equations in a and b. We will get two equations in a and b. And if we solve these equations, we can get best estimates for a and b. With these estimates, line y equal to a plus bx become the line of best fit. We can prove easily. Now we are able to just prove it that this too will be positive, right? This is very simple. We are able to prove it. Now, so let us take one example. Then it will be very clear. Now the example number 1 is what? Fit a straight line to the following data by the method of least square. So given data is what? The value of x are given 0, 1, 2, 3, 4, 5. The value of y are given 5, 13, 25, 36, 48, and 60. So now here we have given the data set over here. Our set of 6 points are given. Value of x and corresponding value of y. So what is our aim? Our aim is to find out the straight line using this data set. So let the straight line be y is equal to a plus bx. Let the straight line be y is equal to a plus bx. Now, by the principle of least squares, the normal equations to be estimate a and b are, what are the normal equations? So now we have to learn this normal equations, because if we are not able to learn, or if we are not remember about it, then we have to again prove from the beginning. So this is the best practice, that if we learn these equations. So now sum of yi is equal to na plus b sum of xi, and the second equation is sum of xi yi is equal to a times of summation of xi plus b times of summation of xi whole square. So these are two normal equations. So with that, now we are able to make a table for calculating the value of sum of xi. So the x is given, it is 0, 1, 2, 3, 4, and 5. Corresponding value of y are 5, 13, 25, 36, 48, and 60. Now, we have to multiply x into y. So 5 into 0 is 0. 1 into 13 is 13. 2 into 25 is 50. 36 into 3 is 108. 48. So 4 8 is 32 and 4 4 is 16. 16 plus 3, 19, 192. And similarly, 5 6 is 30, 300. So these are the multiplication of x and y. Similarly, we want to find out the x square. So x square is 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, and 5 square is 25. So if we adding all this thing, because we have to substitute the value of sum of xi. So how we get the sum of xi? So sum of xi means we have to add all this term. So 0 plus 1 means 1 plus 2, 3. 3 plus 3 is 6. 6 plus 4, 10. 10 plus 5, 15. So this is the 15. Similarly, we are able to add this also. It should be 187. If we adding all this thing, we are getting 663. And if we adding x square over here, we are getting 55. Now, we have to substitute all these values in these two equations. So substituting the totals means sum of xi, yi, sum of xi, yi, and sum of xi square. And the total number of terms, how many total number of terms? So 1, 2, 3, 4, 5, 6. There are 6 terms. So let us take the value of n is 6. And if we substitute all these values, what is sum of yi? So sum of yi is 187. So we have substituted sum of yi is 187. N equal to 6. We don't know what is the value of a. We have to calculate it. And again, we don't know what is the value of b. We have to calculate it. What is the sum of xi? Sum of xi is 15. So we substituted 15b. Same thing for the second equation. Sum of xi, yi, it is 663. Then sum of xi, it is 15. A, and sum of xi whole square is 55b. So this is two equations, two simultaneous linear equation in A and B. So now we know that we have different method to solve this system of linear equation of two variable. And if we are able to simplify it, we get the answer as A is equal to 3.2381 and B is equal to 11.1714. And so from 1, if we substitute all these values of A and B in the equation number 1, we are able to get y equal to 3.2381 plus 11.1714x. So this is what it is, the best fitted straight line using the data. Now, what is the use of this thing? Now, if we are able to find out what is the value of y at 3.5. So also if you put x equal to 3.5, we are able to calculate the value of y. So any value, even though we are also able to get what is the value of y at x equal to 10 or x equal to 100, we are also able to calculate it. So this is the very much applications of method of least square using the curve fitting.